All right, guys. Mr. Cubic here, coming from the man cave. These are the notes to go with section 11.7, simplifying radical expressions. So the notes are for Thursday, April 16th, 2020. That's the original airing date. So hopefully, if I end up using these in the future, you guys can look this stuff up. The homework is pages 538 and 539, numbers 3 through 48 mod. So I will tell you there's some easy stuff here, and there's some stuff that's very important that gets kind of hard. This is probably, I think, the hardest lesson left, maybe 11:10. Also remember a couple other things. Number one, I skipped 11.6. That was what we did on Monday. That's on the Pythagorean theorem. And then number two, we have a test next Friday, which is 8 days from the day of this lesson. Okay, so let's go ahead and get started, and you can see the first one I have here. So basically it says simplifying radicals, but I'm not going to lie to you. All I'm doing here is I am multiplying or dividing square root terms, right? Radical terms. So as a general strategy, okay, I'm going to say we're going to say multiply the things outside the house. Okay, so I would do on the first thing 5 times 8, right? Then I probably would multiply the things inside the house, right? So here I would do root 3 times root 21, right? And then we're just going to go ahead and simplify. Okay, so that's what we're doing in this lesson. I don't think it's the hardest thing in the world, but I do think you need to see a bunch of these so you know what they look like. So here, this is 40. Okay, and here, let's just go ahead and say that that's equal to the root 3 times the square root of 21, which is root 3 times 21, which is root 63. Okay, so your answer you could say is 40 root 63, which would be technically correct, but you could still simplify. Okay, so when I go to simplify this is going to be root 9 root 7. So I have 40 times 3 root 7. So this answer is 120 root 7. So that's just the easy one for you to see, right? So you do 5. We do 5 times, hold on one second, hopefully this is still, okay? We do 5 times 8, which is 40. And then we do root 3 times root 21, root 63, which is 3 root 7. So there we go, all right? Now, I told you there's a few things here that maybe are kind of weird to you, so I'm going to do this one, and it's misleadingly simple, okay? So I just want you to know this is something that you will be seeing on the test. It's very important that you understand this, okay? And what you need to understand is, okay, you never, okay, ever, right, leave a square root in a denominator, okay? So this is something called rationalizing the denominator, okay? And we're going to spend an entire lesson on this next Tuesday, okay? But for right now, we're doing sort of an easy way to do it. So it's really important that you understand this idea of rationalizing the denominator. So one of the questions, let's go slow here, okay? So when I go to do this, okay, the first property that I know here is that this is equal to root 1 over root 2, which is equal to 1 over root 2. Okay? So that's the first thing you need to understand, is this is equal to 1 over root 2. Now, one of the questions that was on the quiz that you took on Monday, one of the questions that was on there was the square root of 2 is irrational, true or false? And the answer is that is true. There is no fraction equal to the square root of 2. That's why Pythagoras killed that man, okay? Was because he thought it would work out a little bit simpler. All right, so it doesn't quite work that way. I can't just leave it like this, okay? So it's okay to have a square root in my numerator. It's just not cool to have a square root in my denominator. So how can I fix this? Well, I can fix this by multiplying by root 2 over root 2, okay? Which is going to give me root 2 over root 4, which is root 2 over 2. So it's just kind of an odd thing, right? But this, the square root of 1/2, is equal to root 2 over 2. Okay? And so whenever you see a fraction in the denominator, you're always going to rationalize it. And we will spend an entire lesson on this. Okay? But this is the thing that I'm worried about. Everything else is easy. This is the thing you need to learn. All right, so I'm going to move on to, I'm going to go to olive. Okay? So olive drab, right? So we could use this in the army. All right, so here's number 3. Root 10 over 13 times root 27. I'm sorry, that should be root 10 over 3 times root 27 over 32. So what am I going to do? Well, one of the things, remember, root A, root B is equal to root AB. Okay? So I can make this root 10 over 3 times 27 over 32, all underneath this same bar. Okay? Now I could multiply it right now, but I think it's a little bit easier if I do my reducing. So this is a 1, and this is a 9. This is a 5, and this is a 16. Okay? So I end up getting here, right, the square root of 45 over 16, which is equal to, I don't know why it's going in and out of focus like that, root 45 over root 16. So hopefully you guys know that the square root of 16 is 4. So my denominator is 4. It's okay to have a whole number in your denominator, nothing to panic about. Okay? And this root 45 is going to be root 9 times root 5. So my answer is 3 root 5 over 4, which if you wanted to, you could write this as 3/4 root 5. Okay? So these problems with the fractions are where I'm a little worried about you. I don't think they're brutal, but I do think you need to kind of see them, right? It's just sort of these things like you would never know to do this stuff unless somebody told you. Okay, so let's go to this next one. All right, and again, there's no sort of one answer for us to have. I'm just going to do as many of these as I can. I mean, there's a lot of things I could do here. So let's go ahead and do this on this one. Okay, so root 75 is going to be equal to root 25 times root 3. And root 18 is going to be equal to root 9 times root 2. So let's just do the ones that I do know how to do. I don't know why that's doing that when no one's moving. Why is it doing that? Like, that's bizarre. There we go. All right, so I get 5 root 3. Okay, where did the 5 come from? The square root of 25 is 5. Okay? And I'm going to put that over 2 times 3 times root 2. So I get 5 root 3 over 6 root 2. And you might want to stop there and you might be like, I'm the sweetest, right? Everyone look at me, I'm so sweet. The problem is I have a square root in my denominator. Not good, okay? So I'm going to multiply by root 2 over root 2. And I get 5 root 3 root 2 over, right, 6 root 2 root 2. So I get 5 root 6 over 6 root 4. The square root of 4 is 2. So I get 5 root 6 over 12. Okay, so that is the answer to that example. All right, so those are the 3 problems I wanted to go over with you. Again, you probably could do all of these in about 5 different ways. So I have a lot of problems to do. So what I'm going to do is I'm going to go through them so my video isn't super long. I'm going to go through them pretty quick. Okay, I would suggest that you pause, try it on your own, and then do the problem. Okay, so we're going to start off. This is number 2 from your homework. Your homework is multiples of 3, so you're not going to do this one. But this is number 2. Okay, pause and do it on your own. Then I'll do it for you. So this would be 4 times 2. So those are the things outside of the radical. And then root 7, those are the things inside. So I get 6 root 49. The square root of 49 is 7. So that's 6 times 7, which is 42. Again, I'm going to move on, but you can go back and do this. I basically did the exact same as the first one. Okay, here's another one. I don't think this is very hard, right, if you just kind of go through and do the way you want. Okay, root 3 root 27, right? Well, that's equal to root 3 times 27, which is equal to root 81, which is equal to 9. Are you kidding me? Right? Thought these were hard, Mr. Cubic. Yeah, most of them aren't going to be bad. I'd say if there's no fraction, you should be able to bang it out. Okay? All right. I think this is purple. It could be brown. It's kind of overcast. All right, so I have 5 more to do. Okay, so let's start off with number 14. Okay, we're getting those fractions. Okay, so this one, all right, pretty good. Not great, but pretty good. All right, so I'm going to go ahead, and I know that root A times root B is equal to root AB. So I'm going to make this the square root of 4 over 27 times 9 over 4. So now I cancel. The 4's cancel. So that's nice. They're both 1s. The 9 cancels off of the 27, so that's a 1 and that's a 3. So I end up with root 1/3. Right? A lot of work. But now you got to be careful because I technically have a radical, right, in the denominator. Right? I have a denominator in the radical, so it's the same thing as a radical over the denominator. So I would make this root 1 over root 3, which is 1 over root 3. Now I'm telling you, this is where I worry about you. It's not hard, and I wish maybe I'll do a homework just of this. Okay, so I have 1 over root 3. It is incredibly rude to have a square root in the denominator. Okay, so what am I going to do? I'm going to multiply by root 3 over root 3. Put up my little thing. That's a form of 1. You're allowed to do that. It's a funky form of 1. Root 3 over root 3, but anything over itself is 1. So here I get root 3 over root 9, which is root 3 over 3. Good little problem. I like it. I like it. Baby likes sauce. Okay, so again, please pause this as I move on. I have 4 more I want to do, and I'm already at the 14-minute mark. Okay, so I want to try and do this one. This one, again, we have a fraction, so let's go ahead and go slow. there's a lot of ways I could do this, so please don't think you have to do it my way. But I would say that this is equal to 3 times root 48 over root 9, which is 3 times root 48 over 3. So these guys cancel, and all I have left is root 48. Now this is the sort of one, you might think this is hard right now, but you're going to be able to, as soon as you see it, you're going to know what it is. Maybe not this year, but next year, right? So you get root 16 times root 3, which is in fact 4 root 3. So my answer here is 4 root 3. All right, so I actually skipped ahead. I don't think 35 is a good problem. I will tell you, I probably wouldn't ask you one like this on the test, but there are some like this on the thing. So just go through our rules, multiply the things that are outside the square root, right? So here I get negative 5 times negative 2, right? So that's going to be the outside, negative 10. Then I multiply the things that are inside. So root mn squared root m. So I get the square root of m squared n squared, right? Which is the square root of m squared times the square root of n squared. So my answer here would be negative 10 absolute value of m, absolute value of n. And most people wouldn't write this as two separate ones. So you just say negative 10 absolute value mn. I just don't think that's hard. You know, I know we have but my lying math trick for morons, right? And again, when I teach it to you and you're like, oh, this is easy, I'd rather you think it's easy and comfortable doing that. Okay? So 2 more, and this next one is, I'm going to say, one of my favorites. So I'm going to put this 3 hearts next to it. I just love this problem, okay? And you'll see why, hopefully, in a second. So I'm going to do it a little bit different way, okay? And there's lots of ways you could do this, so don't feel like you have to do it my way. But I would make this equal 15 times root 6. And I'm going to tell you, I happen to know that root 90 is equal to root 15 times root 6. Okay? Now again, there's about 10 ways I could get you here, right? But this is the important place for you to end up. So I have root 15. So again, if maybe you don't understand, right? So root 90, well, 90 is equal to 15 times 6. So root 90 is equal to root 15 times 6, which is equal to root 15 times root 6, which is where I got there. Now, why would I ever do that? Why? Because those fellows cancel, and I get 15 over root 15. And you're like, okay, I got that. That's the answer. No, it's not the answer, right? Because I have a square root in my denominator. Can't do this, okay? So I need to make this into a math trick for morons. So I'm going to multiply by root 15 over root 15. And for my numerator, I get 15 root 15. And for my denominator, I get root 15 squared. If you care, right, it's 15 root 15 over, I think that's 225. Right, doesn't make a difference. I think this one's easier to look at. Because that is a math trick for morons. So I get 15 root 15 over 15. This young man cancels off of him, and my answer to all this problem is root 15. Crazy! Crazy. I went from there to here? What? What? That's right. All sound math. Every little bit. Alright guys, one last one. and then I'll cut you loose. So I think this is going to end up being like 21 minutes. I'm going to go with Limey. This is not the sideboard. This is my desk. Okay? So again, it's possible that you have to distribute. I think there's one. This is number 38 on the homework. So maybe 39. You'll have to do this. So again, all I'm going to do is share this root x with everything on the inside. So I get root x to the 5th plus root x times 7. I can put it all in parentheses if it makes you feel fancy. So here I get root x to the 6th plus 7 root x. If you've been playing at home, you would know that the square root of x to the 6th is x cubed. So my answer is x cubed plus 7 root x. Now I will be honest with you, technically that is going to be an absolute value. But starting about this lesson, the book stops putting it in the back. So if you put either of these, I'd be fine with it. That is technically correct. That's what's in the back of the book. All right, guys, I think there's going to be a lot of questions. So remember, you can email me, you can call me, you can text me, you can FaceTime me, or tomorrow is Friday. I will be there to answer your questions from either 10 to 10:30 in 8A or 10:30 to 11 in 8B. All right, guys, good luck. Miss ya. Stay safe.